Hello, my name is Sean Gillespie. I am a single subject credential pre-service teacher in the area of science. And today I wanted to look at a Richter scale. And we're going to look at how do we read that scale when we consider literacy in the area of science. So the first thing when we look at a graph, or any graph, is we want to identify the title. And so you see right here, it says that this title is about a Richter scale. It lets us know what are we looking at. It starts to frame our mind about what things we should be considering. So we immediately know that it's a scale, and if you know anything about the Richter scale, you know it has to do with the magnitude of earthquakes. And so quickly along the right-hand side here, I can see they have examples of earthquakes from different years and the locations or their titles matched up with their magnitude along the scale. The second thing I look for on a graph is I want to know what are the x-axis, which is down here, and the y-axis. So very quickly I can see that the x-axis has a scale of 1 going from not felt to felt, and then we can see its measurement in microns. And so in addition to seeing the scale, I'm looking for labels of units of some sort. And so I see that right here on the left as well. So those are the first few things that immediately I need to know in order to make sense of a scientific graph. Now, in our graph that we're looking at for this particular one, we see internally that it does have labels to give a qualitative indicator of what the quantitative measurements mean. And so very low on the graph we can see that it indicates that earthquakes with a magnitude of a 1 or a 2 times these measurements on the left are really minor or not felt. And as we go up it, we see an exponential growth that is needed in order for the strength of that earthquake to increase. And so we can see that an 8.9 is dramatically more destructive than even a 6, even though it doesn't move very far along the x-axis. But the measurement along the y-axis grows dramatically. And so being able to see those in comparison allows us to kind of have an understanding of how we read this graph telling us about the strength of earthquakes. There's also some terminology when looking at a graph like this that I would need to understand to be able to make sense of it. I couldn't just walk up and understand this graph without some previous knowledge or common terms. A few of them that would be necessary is the word magnitude. We would see this word hopefully in math early on, meaning just the value of the term, whether it's negative or positive. But here it has to do with the strength of an earthquake. So this word magnitude has a domain-specific meaning, but it also has some value in other fields and other domains. The word microns here, understanding that a micron is 10 to the negative 9th. And so that is part of the scale that we need to understand, which you may know from math or some other place as well. And then we see a couple more. We have the word amplified, and so that just means how it is multiplied out. Without understanding that, that would be difficult to understand. Then there's logarithm, which would be something most people would have learned in math. And so it's pretty specific to a math understanding with an application here in science. I think the last thing I'm noticing on this graph is I see seismogram or seismograph, and so those have to do with indicating the way we measure earthquakes. So a seismograph is the device that measures earthquakes, and so we can see that that's kind of indicated here that it's 100 kilometers in distance kind of from the location. And then the epicenter, which is, as I mentioned, the seismograph indicates it's 100 kilometers away from where the earthquake took, and that earthquake took place at the epicenter. An epicenter is where the earthquake originates. So without these terms, we wouldn't have a full understanding of what's going on in this graph. And so there's some domain-specific terminology, but a few of the words, as I mentioned, such as magnitude or logarithm and microns, will be found in other domains of study as well.